Yo, yo, yo. Good morning, good morning. Okay, let's see if we can close this up today or tomorrow, this tessellation stuff. So yesterday we implemented proper tessellation based on distance. In our previous solution we have taken a few shortcuts, which resulted in something that worked, but maybe not in the best way possible. This time around, we went a little bit of a different route, tried to perfect it. So previously we basically did it on the edges of each subquad. This time around we do it based on the closest point on an edge to the camera. Although we are doing sort of a one additional split or one additional tessellation, but we do it in the geometry shader. So we can see here that this is roughly the most amount of times we tessellate something, and then we always do one last tessellation in the geometry shader, because then we can improve the topology as well, make it into these. I think there is a name for this type of topology. I just don't remember it. So instead of splitting quads into 2 triangles, we split them into 4. But when we had this in place yesterday, we noticed that the last tessellation we do in the geometry shader, it might be a little bit weird or result in something weird in certain cases. I think this one is one of those cases. So here, like when we do the last tessellation in the geometry shader, it's extremely important that we're working with a triangle from a quad. So I'm talking about these types of triangles, but because what we are doing in the geometry shader is that we split this triangle into 8 triangles. I don't know if it's, or actually is it 6? We'll see. Or no, we split this triangle into 4 triangles and a quad into 8. So if we take a look at this triangle and we add the final split, we get something like this. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, say the first note was the correct one. 8 triangles. And we do it by some interpolation math at here. So we interpolate this point, and this point first, and this point, and this point, and this one, and then we create some triangles. The problem being is when we get something like this, and this happens because this subquad has an even subdivision over the full subquad. Each edge get the same subdivision amount. We try to be a little bit more flexible on that right here, and one error I can see instantly is, or one thing that we need to change, is that our inner edges, so this one and this one, they need to have the same, or we want them to have the same subdivision amount, otherwise we're gonna get rectangular quads in the center, and I don't want that at all. But then we have this issue, and this issue is that this edge right here has a higher subdivision amount than the inside of the quad. This one is going to be a little bit harder to solve. We can't really... If we add our last set of tessellation here, the one being done in the geometry shader, each of these 3 triangles are going to turn into 8 triangles, and we get a pattern like this. And honestly, I don't even know if it's that bad. It's probably gonna look not great, and it might result in... it's definitely gonna result in some popping, I reckon, because some of these are actually... It's a question if... Yeah, it's gonna result in some popping, because we create... Oops. We create some vertices that are gonna change position. Okay, so I wanna see what happens with this one if we fix... I mean, this solution is... Like, I don't know how good it is. What I'm trying to say is, I don't even know if the result from this dynamic tessellation will be good enough to use, or like if it's really worth using, or if we should just go back to the previous one of tessellating the full subquad the same amount. We're gonna try and see what happens with these if we interpolate the middle the same amount. Yo, what's up, Chilled? I last checked on your last time like 9 months ago. Welcome back then, I suppose. I need your level of dedication. It's just the last years I've had this dedication. Previously I was prone to... what is the word? Off-put my work and hate myself for it. But okay, we're gonna start with tessellating the inner quads the same amount, and then we will see what happens. I'm a little bit... When I see shit like this, I worry. In this case, we don't get any additional points. We don't use those. That's good. So what I'm thinking about doing instead is, if we go to the script and we have distance inside 0, here I just want to take the max of the edges, I think. Yo, what's up, Fabic? How are you doing today? I just saw this morning that you finished your mech. Very nice, very nice. Chilled procrastination. Yes, that was the word I was looking for. I would lie if I told you that I don't do it anymore at all. I still do it pretty much, a lot. Streaming definitely helps not doing it during game dev though. So I think what we want to do here is we want to take the max distance inside 0 and distance inside 1 should always be the same, and it's going to be the max of these. So we just do this, 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 and then we do max, max, max. You can keep it on separate lines. Three, 2, 1. Oh yeah, we output dot inside 0 and 1. Yeah, I think we will probably do something like this. I'm a little bit worried about what will happen with these though. So we see this one right here. It should be okay. Will it? That'd be good. The models are finished. I can finally go back to game dev. Welcome back to you as well. Yeah, everything is moving forward. Starting to grow a little bit tired of shader work. So as soon as the snow is in place, we're gonna move on to some gameplay. Much needed gameplay. But other than that, yeah, I'm fine. We're finally starting to find the sweet spot for how the terrain should be structured. Terrain, water, snow, and so on. I honestly don't know. Let's see here. Let's change this one to... Yeah, this stuff... Oops. This stuff right here doesn't look so good. With our last split. So it's always gonna be... Yeah, look at this one right here. This is gonna be fucked. But okay, how should we approach this? Yeah, because this won't work. And okay. Fabi, sorry for the distraction, but may I ask about the mesh selection? I assume the visual selection just looks weird. Oh, you mean the orange one? Yeah, Unity has a hard time, or this selection visualization doesn't work for some reason. It doesn't perfectly work for quad meshes. Which I found, like, if we create a quad mesh in Blender and we import it as a quad mesh, then the selection works. But if we create a mesh during runtime and set it to mesh topology quad, it doesn't work. Okay, so my problem here is we're gonna take this. We're gonna move it down. And then we're gonna take it again, duplicate it. So this one is what I'm afraid of. Then if we do our final split, we are gonna get Yo, what's up, Catboy King? Why can't... Oh, okay, font color. Are you winning? Well, we'll see. We actually don't get these, do we? Sent you something on Discord, let's check it out. Yeah, we have looked into multiple different videos. I'm gonna check this one out after the stream as well. The problem is that most of these videos leave it at okay, so the problem with most of these videos is that they are finished at the same point that we are. It's just that we are trying to improve upon that right now. So like stitching during tessellation is something we already have in place with our old solution. But the problem is that our old solution, we don't get as smooth. So the problem is with our old solution, we do it with these. So our old solution is finished at this point. And look at this, like we have perfect stitching here. Like the tessellation works, we have perfect stitching. If this sub-quad is only tessellated one time, the edge here is tessellated as many times. So this edge for this quad has the same number of vertices as this edge for this quad. So like right here, what we're looking at is perfect stitching. If we were to displace this, you wouldn't see that it was different sub-quads, right? And this is the same state that we had our previous solution at. The problem is that when you do tessellation, you get quads. The tessellation pretty much... The tessellation controls how... Or it's actually the... it's the step after the domain shader that triangulizes your quads. So the tessellation has full control over how our quads triangulizes. So for instance, the tessellation usually does something like this. So if we take a look at this quad right, which quad should we take? We can take this quad right here. So usually when the tessellation for my hardware, etc, etc, it triangulizes it like this. So we can see here that quads to the top left of the center point, they triangulize like this. So you get a line from top left to bottom right. And these are from top right to bottom left, and yeah, on and on it goes. How these quads triangulate deeply affects the visuals of this when we displace it. So when you displace it according to a height map, you usually want the cut in the middle of the quad to be perpendicular to the slope. So you get a much smoother surface, right? So one fix to this is just in the geometry shader, where we get triangles though, we just check, is the middle cut aligned the way we want it with the slope? No. If so, flip the quad, otherwise leave it as it is. Right, then we will get nice triangles that are aligned with the slope. But if we're gonna do quad flipping, that will take as many resources, pretty much, maybe even more calculations, than just taking all of our quads and controlling the triangles, the triangle split ourselves, i.e. adding the last tessellation stage that leaves us with something like this. So this improves our visuals of the terrain. If we displace the height now, it will look much smoother, even at points where it previously did not. By doing this, we also force our last step to do the last tessellation. So we can see here, we take one quad and turn it into 4 quads. And this is beautiful, because then we know that this point, like this, and what is it? This. All of these are new points, and we can adjust the height of them so we reduce popping. And this, like splitting the quads like this, is the new approach we're trying to add to our old approach to fix much of the problems we had with that one. It's just that by doing this old approach, we now have a seam problem. But listen to me now. We don't have a seam problem in the case of if we displace this by height values, the seams won't be visible, because we can see here that the seams, this quad's edge still has the same amount of vertices as this quad's edge, right? i.e. they will read from the same heights and we will have no seams. So usually what you can get is, let me draw something here. With that being said, so usually you get, you can get, if we have one edge that displaces like this, and then you have one edge that is located at the same position, but it has a much higher resolution, so you might be getting something like this, which means that at these points you can see through the terrain because they are not aligned. That's not a problem we would have here. I'm gonna go into what the problem is, one sec. But with all of this said, Fabic, I appreciate the video and I'm gonna look through it later on, because what I've found is that, like, a lot of people do this stuff and everyone does it a little bit differently, or some do it a little bit differently, so there's always something to pick up and learn. Maybe he goes through something I haven't thought about that I can apply to my stuff. So like, every resource on a problem I'm working on is very much appreciated. So like, keep sending and keep writing feedback. It's just that I just want to state that this problem right here is extremely specific for the method we are currently using. So with this approach, the problem isn't that we will get a visible seam between quads. The problem is that the split between quads, when we have rectangular quads like this, we will get, so when we do the last split, we assume that we get these sort of triangles. So triangles created from a square. But here we get 3 triangles, one of which is created, or all of which are created from a rectangle. This one is from a square, this one as well, but this one is not. And we don't really split this one ourselves currently. We can, I think we can do some extra calculations in the geometry shader to first split this one into something like this and then do our original approach, right? But it's gonna take a lot of calculations. Okay, Fabic, so the problem, feel free to ask questions. I'm gonna try and explain it as good as I can. But okay, so when we enter the geometry shader, we send down each triangle here on itself, right? One sec. One sec, I seem to be having problem with my YouTube stream. Yo, what's up, Bruce? Maybe force it to split even amount. It looks like the problem is in odd number. I'm gonna try and explain exactly what the problem is and what we can do to solve it. Okay, Fabic, well, welcome back. I don't think I have any error on my end. It looks to be alright, but given all the recent problems I've been having with my computer, I wouldn't be surprised. Okay. So, what we are doing currently, I'm gonna show the problem, I'm gonna try to explain it as good as I can. Feel free to ask any question, anytime. And yeah. Like, this is how it looks in runtime. And this is related to the problem. So I'm gonna show in a figure here. Like, this is the problem at hand at runtime. It's just that we use the scene camera instead of the game camera. But okay. So we create a mesh on the CPU and we send it down to the GPU. It's a very low resolution mesh. And then we have a set of tessellation stages in the shader. Okay. At the end of the tessellation stages, we end up with something like this. Ignore the green vertices. So we end up with something like this. It's we subdivide the mesh in a quad tree fashion, so every quad becomes 4 quads and so on and so on. And then we send down this result, the white vertices, to the geometry shader. In the geometry shader, we do one last custom split. So in the geometry shader, we get triangles. So for instance, we get this point, and this point. So we get this triangle made of these 3 points. What we do in the geometry shader is that we subdivide this triangle one last time. This time, however, we want to subdivide it with a lot of constraints. We want every triangle in this triangle to be the same size and located in a specific way. More specifically, like this. So in the geometry shader, we add this, and this vertex. Together with the original vertices, we then triangulate it and return smaller triangles. So we end up with something like this. Looks beautiful, works beautiful. Right? The problem we're having is when one quad that is subdivided X amount of times is located next to a quad that is subdivided X minus 1 times. So we send down this triangle to the geometry shader, we create this subdivision, and we're done. When we send down this one, or the problem is really that we don't get this one here in this case. What we get instead is, or the tessellation returns fuck, am I... No, the tessellation returns Okay, because the tessellation knows that this edge for this quad is tessellated one more time than this edge for this quad. So we end up with something like this. So I wish I could hide these. Come on. Ah, fuck it. Ignore the green points. So our result from the tessellation looks like this. Okay. So when we do our custom triangulation in the geometry shader, this triangle will be subdivided the exact same way as this one. So we will end up with I'm just gonna do this for clarity. Bum 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 bum. So we have no problems with this triangle right here. I think it can be seen. This triangle right here, that's this one roughly, located a little bit differently. You see this triangle gets tessellated perfectly. We split this one into like that, and this one like this, and this one like this. The problem is this one. Yo, by the what's up, by the way, Diligence? This is polygon optimization, definitely. And what's up, Nathaniel? How's it going? It's going pretty good, I think. We have a very interesting problem here we're trying to solve today. And the reason we split this triangle like this is because we never want to create new vertices, or we never want to move around vertices or create vertices that will later be removed. So a created vertex, if we increase the tessellation, that created vertex should always exist in the next iteration. And I think that holds true here. So in the next iteration here, we would get a subquad like this. Yeah. So if we take the same logic we use to split these triangles, the same constraints, and we split this triangle, what we get then is, first of all, I think our first check fails. So what we do when we get a triangle like this is we identify the diagonal line. Yo, what's up, Ling Ling? And we identify the diagonal line by doing a simple like this. If a point, we give it 2 points. If the points have different x coordinates and z coordinates, it's a diagonal line. So for this triangle, we would get a diagonal line here and here, but not here. So for this triangle, we get 2 diagonal lines, while we only get 1 here. And our full algorithm goes into the shitter. So if we're being fed a triangle like this, we need to do one pre-process before we subdivide it like this. So given this triangle, we should be able to identify the non-diagonal line, this one, and then we just add 1 point, then we just add 1 vertex here, split it like this, and then we have reduced our problem to a problem we already solve. pretty much how it goes in computer science, right? Take a problem, reduce it to a problem you know, and then solve it. So we're gonna have, if we want to rely on this, we have to do something like this. But, big but, this is the best case scenario. Let me show you another problem here. So here we can't do the same thing, right? So what we're seeing here is I don't even know where to begin with this one. So this problem, or this reduction of problem, is only possible if we have exactly this setup. So we go from subdivision x to subdivision x minus 1, but if we go from subdivision x to subdivision x minus 2, we get some real fucked up triangles, and we're not able to solve it the same way. So the crude way to do this would be to just take every exception into account, solve them each, and yeah, I don't want to do that. I wonder if there's a smarter way. Lily, how are you all doing? I'm doing pretty okay. I have been fighting this cold for the last week or something like that. That sucks, but everything else is okay. How about you? Is the problem clear here, or do you have any questions? The problem is, if I do a too long didn't listen summary, the problem is our custom subdivision doesn't optimally work for dynamic tessellation. It works, it hides the seams, but it removes one of our constraints. One of our constraints is that we should never create new vertices in our subdivision that won't exist in the next subdivision stage. Ling, I'm good. Finished most of the backend for a website. Nice. My frontend buddy is not doing his job though, and I wanna learn Angular. Been there. I've been on both ends on that actually. It sucks either way. Can't you do Angular? I'm trying to remember what I did for my last web app for front end. Some Node.js library, I don't know which one. Fuck. I'm wondering why we're subdividing it all. What's wrong with the big triangles? We're subdividing to get better topology. So, or first of all, we're subdividing to optimize. When we look at the terrain from very far away, we don't want to render as many vertices. When we're looking at the terrain up close, we want to render it with a lot of vertices to make it look smooth, okay? And then we do the last subdivision like this to remove some of the jagged edges we get with the other topology. So it's actually this last stage that is the problem currently. Nathaniel, what's the issue with moving the existing verts when subdividing to the next LOD? If you move the vertices around too much, you're gonna get like a moving terrain when you walk towards it, right? So you might be seeing from far away. Let's go with worst case scenario. From far away, you might be seeing a peak like this. And then if we subdivide once more and we let the points move freely, this peak is gonna maybe be turned to something like this. So in the initial one we have 3 vertices, then we subdivide it once more. We have removed the quad tree subdivision form. So from subdividing this once or adding 1 point, we add 2 points. So this point, when we move closer to this one, first of all you will get popping, but we can solve that probably. But yeah, you will get widely different silhouettes if you move points around in the X and Z coordinates. Moving points in the Y coordinates, so up and down, that I'm fine with. So what we're doing in our solution is that we have this one. In our last subdivision, we add this point and this point. Initially, we let these points just have a height that is interpolated between these 2 points. So when we move closer to this peak and we render it with more points, it will look just like this. But then when we get closer and closer, we move these points a little bit in the Y direction. So the final result might be something like this. And this I'm entirely okay with. So if we just have points sliding up and down, it's barely going to be visible but from far away. And our solution works with this. But if we slide them in the X and Z direction, we will get too much movement and it will be extremely visible when the character is moving towards a peak. Yeah, I'm gonna check the Discord, Fabic. And I just want to check, I just want to do one thing as well, or explain one more thing. This topology is, let's see if I can draw this. It has been a while since I tried to draw stuff in 3D. Let's bring this one down here. What do we have? Oh. 3D cube, right? Our main problem... Ooh. Let's draw this line here as well. Our main problem is when we have... When this point and this point and this point has the same height, but this point is located down here. What we get then is terrain that looks like this, right? It's not visible at all here, but the idea is that these 3 points together create a very jagged edge. So our snow might look like, if we run diagonal in our snow, the edge will look like this from above, and that sucks. And that's the problem we solve by adding... so here, this one would be up, up, up. Or actually, this one would be up, 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 and this one down. We will get a jagged edge here. But when we introduce a middle point, like this, we subdivide one more time. But if we were to only introduce this middle point here, we would get a little bit more of a slope going here. So this triangle would be sloped, and that would be amazing. So that's the problem, the visual problem we solved by doing, by ordering our topology like this instead of like this. So that's the problem we solved by splitting quads into 4 triangles instead of 2. Okay, let's see Fabric. I just want to check this. Sorry if I mentioned it before. Average height. Yeah, that is exactly what we do. So like the height, is not a problem at all. When we create points from 2 different points, so let's see here, what this method does is it takes a point, or it takes 2 points and creates a new point between those 2. So we send in this point and this point, right, to this method, and then we create a new point in the middle of it. So we create this new point. For this new point, we create 2 points that represents the same point. One that is called interpolated point, and one that is called final point. Because underneath all this, we have a height map. So the gray one here are pixels, right? So when we create this point, we create one that is interpolated point. The interpolated point is just a point interpolated along this line between these 2 points. That's our interpolated point. So that's basically the average height of this and this. So that's this one, right? Then we also create a final point. The final point is this point. It has the same x and z coordinate, but this final point reads its height from its own pixel. So after these 2 codes, we basically have 2 points at the same position here. One that is interpolated and one that actually reads its original height value. The final thing we do before we return which point should actually be located here is that we interpolate it one last time. So depending how far away this new point is from the camera, we interpolate it. So if it's very far from the camera, it means that it's pretty new. So we just let it be the interpolated point. We have created a new point, but the position of it is as if we had no point there at all. When the camera moves closer to that point, we interpolate it more towards the final point. So i.e. this point will change height towards its final height. We will get a little bit of a fading when we move closer. Yeah. Ling Ling, I also have another meeting for a group project in school. Yeah, that's relatable as well. That is relatable as well. So, like, once again, the problem is not how the problem is not it's not the heights of the new points. That's no problem at all. The problem of the new points are the x and z coordinates where we create them, because this is a triangle we did not anticipate when we wrote the original algorithm for creating new points. So the new points we create here, they will have the correct height to minimize seams, I'm pretty sure, but they will have a location of x and z that goes against one of our constraints. It's a pretty complicated problem. I don't doubt at all that we will be able to solve it. It's just a question of how we want to solve it. Okay, Fabrik, you might be onto something. I'm gonna try and see if I can understand this. Don't do wired tessellation or weird tessellation between chunk boundaries. Just tessellate it normally. Just average the heights of the vertex between the chunks. Okay, I get you. I like what I'm hearing. Yeah, I'm sorry for not catching along earlier. I have a lot of things in my mind right now, but you're definitely onto something. But I don't think it will work. Let's see here. I'm thinking about it. Okay, so if we take the easy problem first. Okay, so at some point, like somewhere along the full mesh, we're gonna have so somewhere along the full mesh, we're gonna get to a point where subdivision X meets subdivision Y, right? And it's up to us how we handle it. So we can probably identify it pretty easily here, I think. So if we identify this to be one of these problems, so what we could do is, so let's see, Fabrik, if I understand you correctly, because I think we can. So let's say that this is the point where we meet. And we notice that this point right here is at one of those so at this point we create this point for this triangle, but we don't create this point for this triangle, and this point for this triangle we never let it interpolate to final point, right? So we create this point, but we never change the height of it. It's always the interpolated height of these two, which means that we're gonna have a mesh, or we're gonna have an uneven amount of vertices here, but this one is also always gonna have an interpolated value, so it won't be visible. Ling fucking hate that, man. Why don't people see you don't get proper work done by japping us for it? Yeah, some people, they like to... yeah, they don't really like to get work done. Fabic, let's check the Discord. Yeah, Fabic, I think that is spot on. 100%. So our only problem here... Let's see, how would that look? Okay, I think I have a approach we can use. Okay, fuck, this is great. This is why I love getting feedback. And questions. Okay, so right now we do this weird stuff. So if we take a look at this quad, how it's subdivided. This edge is subdivided x times. This edge is subdivided x minus 1 times. This edge is subdivided x minus 1 time. This edge is subdivided x minus 2 times. So we let the subquad itself handle the seam. What you're proposing, we could handle it like this and do what you're proposing, but I wonder if we take your proposition and we offload the handling, or we clean up the handling. So, okay, now I'm rambling, but we take this full quad and we subdivide it x times. Having hard problems in the morning. Yeah, it's both a blessing and a curse. Really wakes you up. We subdivide each full quad the same amount on all edges, so we will never get this problem. But then we just need to identify how many points we should interpolate and how many we don't want to interpolate. Okay, so it would look something like... Okay, I love this, because we don't really have anything to gain by this. It's just, it results in a quad that is mostly interpolated or tessellated the correct way, but then has some weird edges. We tessellate this full quad this amount of times, and then we handle the seams. Okay. So what we're gonna do is these values we send down here. So these are values per edge. So per edge, these are values how much that edge should be subdivided if we were doing dynamic subdivision. So that means that this edge for this quad and this edge for this quad has the same value here, right? So depending on where our camera is located, this edge will have a subdivision. If our camera is located here, this edge will have a subdivision of x, and this edge will have a subdivision of x minus 1. So what we do is that we store this value. So this is, if we were doing dynamic tessellation, this is how much this one should be subdivided. But this full quad and the edge will be subdivided the most amount of times something in this quad is expected to. So this edge will actually have a subdivision the same as this edge. So we will get a very subdivided edge up here. But then when we do this one, and so when we do this one and this one, we just identify if the actual subdivision on the edge is greater than the dynamic subdivision amount, then we leave some vertices, heights untouched. We interpolate those heights instead. Okay, I get it. This is perfect. This is perfect. We're gonna have one problem we want to solve though. Let's see. I like the drawings, yeah. I tried to make them as beautiful as possible this time around because I want to export them to my GitHub repository and have them explained real good. So I remember what we did, and then when I release the devlog and the write-up on this shit, I actually release it with the correct information. Yo, what's up, Viral Air? Okay, I think this is great. So we're gonna do this. We are gonna add, we have edge and inside, and then we have edge points vs here. I don't know. Yeah, we're gonna rename this one. Dynamic or edge dynamic. Okay. We can leave it. Yeah, we don't use these anymore. Edge dynamic. So what we're doing here is that this one is what we actually tell, how we actually tell the hardware to tessellate, and this one is what the hardware should have tessellated it by if we were going with dynamic tessellation. So I mean, by dynamic tessellation I mean that given a quad, each edge is tessellated individually, or each edge has a individual tessellation amount. Okay, so edge dynamic. So what we do here is we do distance edge exponent 0, exponent 1, da, 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 da. So here we set dynamic edge dynamic and then we do input.edge 0, input.edge 1, input.edge 2, input.edge 3. Oh, not input. Output. So now we get something like this. So if we add this one, we get something like this, and that's beautiful. If we were to do height offsetting now, we have reintroduced the seam problem, right? Because we can check here that this point exists for this quad, but it doesn't exist for this quad, which means that if we actually calculate the height for this one given the underlying height map, this one will move up, but we don't have a point on this one to move up, so we will get a seam, right? So the idea with this solution is that we identified this point and this point and this point, and we only interpolate them. We don't offset them to their original data, we purely interpolate them. So that means that this point will get a height given this and this point, which will be the same height as if we didn't have a point here at all. Although I wonder if the only problem I can think of with this solution would be some floating point error. So if we get some floating point values, if we get different floating point values by interpolating manually and not interpolating. But they are, it should be okay. Or actually, no. I don't know how good this is shown on the stream, but you see this flickering right here. That is the problem we get. I just have to double check. We actually have this flickering here as well. There's a little bit of a flickering, but I wonder if that's just because of extremely thin triangles. Fuck. You see this point right here, is it visible? Let's see. Let's do this. Camera node, align with view. I want to do this. Let's see. Okay, if we do disable this one, align with view, do you see this flickering right here? You can zoom in. So we get some flickering here, but I wonder if it's only for... Let's bring back this. See this? I wonder. Fabric, don't you see this? So this tiny blue pixel here. I'm extremely zoomed in right now. It's extremely tiny. This one, oh my god. This is not what we want to see at all. Yo, what's up, Spires? Thank you for the raid. Have a good one. Appreciate it. Damn. Okay, so what is happening here? This is not good at all. I wonder... I think... yeah, I'm trying to find the wireframe where it's corresponding to. It's not that they are not static. So these small holes we see or flickering, they are not static. They are floating point errors. So when we move around, it flickers. Usually far away, we can see some flickering here. So it's very hard to find. So it seems to be... Yeah, we're finding it on the edges here right now. So between... So even though you have points here with a height of 0, the fact that you have... we're gonna get to the bottom of this. It's 100% a floating point error. So... This one has a different height than this one. And we get this. I wonder if it would be visible. I want to try one thing. We're gonna try and do... We're gonna disable the geometry shader. Okay, this is very interesting. Yeah, it's between chunks where we don't have the same amount of vertices. This might be one of the reasons this might not work. Here we have a bright pixel, right? It should be going through to the stream. Yeah, exactly. It's when we get a tessellation difference. Even though I'm gonna see... to main shader. What if we just do... It might be an issue with the texture, so we're gonna do this. Okay. Okay, so what we need to do is we need to... I just want to double check one thing. Actually, so we can't leave the seams like this. The seams, they always need to have the same amount of vertices to reduce the floating point error. It has to do with the... It's during the rasterization stage. So when we transform triangles into fragments, we have one big triangle here, and when we rasterize it to pixels, the floating point errors results in a pixel here not being covered by this triangle. But when we rasterize these triangles, thanks to us having this pixel here, or this triangle here, vertex here, it rasterizes in a different way. So let's see if I can draw this real quick. Think that you have... We can visualize it like this. We're gonna do this. We're gonna show grid. Okay, so each grid is a pixel. Okay. And let's assume that we have... Can you visualize it with terrain height? If we visualize it with terrain height, it will pretty much look exactly the same. How the flicker will look in game. So you're asking me like if it's not visible or not. Let me think. For us to visualize this with height, we're gonna have to implement our solution, even though the solution might not work because we might get flickering. Like, I don't think there's a difference between the problem with or without height. So in this case, we don't change the height of the vertices at all, and we still get this flickering, right? If we would change the height and interpolate the height here, we would still be getting the exact same flickering, but our terrain would be height displaced. I don't think... I'm just wondering if visualizing this with height will give us some information we don't already know, pretty much. If you understand what I'm saying. Or am I not making sense is my question. I'm questioning myself here. If we just offset this by height without implementing anything, you bet it won't be visible. But I mean, if it's visible when we don't offset the height, it will 100% be visible when we offset it by height. Right? I don't really see how offsetting by height would fix it. Okay, so what I'm getting at is if we just offset this by height, without doing some additional fixes, we are gonna get visible seams. Let me show you, and then we can try the fixes and we will see if the flickering exists. I hope you're right, but I would bet on it being very visible. Because I'm pretty sure this is a floating point error together with rasterization. It's definitely solvable, but we're gonna have to add some extra stuff. Do we have offset by height? Do I just say max height? Here we go. Okay, so without adding it's rasterization. So when we try to, so if we have, let's see if I can draw this exactly. It's probably okay, let's see if I can visualize it like this. We have one triangle here, we have one triangle here. This triangle right here, so we have one point here. Let's draw the other triangle in red color. So the red triangle, it has one more vertex like this. The white triangle only has 3 vertices. So in the graphical pipeline, when we transform these triangles to actually fill pixels on screen, this vertex makes it so that this pixel actually gets colored as the this triangle color, but since we don't have a vertex here, we get a little bit of a different projected coordinate here, which tells us that this point is not located close to the center enough of this pixel to color this pixel as this triangle, which means that when we color all of this, this pixel or this part will be not rendered as a triangle, and that's the hole we get. Every other pixel will be colored as a triangle, but this one will not. And the values that determine if a pixel should render as a triangle or not, they are so small that the error we get by representing numbers by floating point numbers actually affects if a pixel is covered or not covered. And this is our entire problem. And this won't be fixed by offsetting by height, even if we take this point here and interpolate it up here. We're gonna try it because this is the solution we initially wanted, but we're gonna double check. I think our solution eventually is gonna have to be to tessellate the edges here. We just add a point here, even though we don't even if we're not offsetting them. So yeah, so what we want to do now, just to make sure that this is true, is that when we generate this point, we want to see if it should be offsetted or just interpolated. So should it be... Actually, I can show this pretty easily, I think. We can just do this. Here we have the interpolated point. UV step, so we just set this one to 0, which means that the height of them will be interpolated point, and we just do an interpolation here. We're gonna have to restart it because we sent down the data during runtime. I thought... Oh yeah, we have to do it in split as well. One sec. We need to reintroduce our geometry shader, and then we can check it out. So, what did I miss? Oh yeah. There we go. Although I wonder... what the hell? UV step. Oh, I'm stupid. One sec. These should be UV step. Geometry shader should be activated, and we can see here what decides if it's an interpolated point or a final point is this test variable here. So it's the test variable we're gonna rely on. Test. I think it's this test. Yeah. So here we always work with the interpolated. Can we get... Can we get the same... I couldn't easily test it with this one, but why? One sec. Yeah, okay. Okay, we can't easily test it. We're gonna have to do the full implementation, I think. Oh. It doesn't lerp bad right now. It does exactly what we tell it to do. It's like we don't lerp the vertices at all right now. The lerping is only active when we do this, and the problem we have is that it lerp every other. So this point it lerps, this point it lerps, this one it doesn't. So the lerping is fine. It's just that the selection of vertices to lerp is wrong. Trying to figure out if there's a quick way that we can test this before we commit to this solution, because I'm pretty sure this solution will yield the same result or the same issue, the rasterization issue. No. I'm thinking of... I think we're gonna do this. Live and learn, yes. But like... So, okay, so we have two solutions. We have one approach that I'm pretty sure... Let's see here, one sec. We have... Okay, so one solution is to just interpolate this one. So we will interpolate it between this point and this point, i.e. it will be brought up and it will be aligned with this triangle edge, right? That's one solution, and that's the solution I think won't work. It will still leave us with the rasterization problem, because we have an edge that consists of 3 points meeting an edge that consists of 2 points. So that's exactly the same problem when we have 0 height offset, so this flickering. But the other solution would be to add points on this one and still interpolate this one. Okay. Or we could add points here and bring them down, or add point here and interpolate this one. So okay, we have two solutions. One of the solution builds upon the other solution. The one I think won't work, so we're gonna do them both. So let's see if we can fix the interpolation here. So basically what we want to tell this part right here is when we do we need to identify this point. Let's see. We need to be able to identify this point. So this is a point that has been interpolated or tessellated when it shouldn't be, according to the dynamic tessellation. This point, the only points we care about are edge points. So we care about points where the UV tessellation is, where the x-coordinate is 0 or 1, or the y-coordinate is 0 and 1. That's the only points we care about. So we can do this. Let's add in the domain shader, we do float interpolate point. So this one will be 1 for points that we should 100% interpolate, 0 for all others. So we can do in our domain shader, then we do, but that's not enough. But let me show. So down here we do output dot interpolated point. Yeah, is equal to we can just do it like this. UV tessellation dot x is equal to 0.0, or UV tessellation dot x is equal to 1.0, or UV tessellation dot y is equal to 0.0, or UV tessellation dot y is equal to 1.0. Interpolated point and then we do interpolated point dot, or interpolated point dot interpolated point is equal to p1 dot interpolated point or p2 interpolated point. Right, and then we do final point dot interpolated point is equal to interpolated point dot interpolated point. Okay, right now, I think interpolated. Come on. My bad. Okay, we don't have any height, but what I want to check is return input dot interpolated point. Okay, so now Fabik have to grab some breakfast. Enjoy that breakfast, Fabik, and hopefully if you get back, or when you get back, we will have solved this problem. I wish. Okay, so at this point, we have marked the edge points. Then we need to check, we only want to mark the interpolated ones. So for this one, that would be this, and this, and this, and this. And for this one, I'm not sure we would get any here actually. So we have to read if or we have to figure out it should only be an interpolated point if this one is smaller than this one. Yes. And how can we figure that out? Problem is that we need to get the correct edge here. If we did bilinear interpolation, how would it look? So if we have a point here, we do interpolate between this one and this one, and then this one and this one. Get this one, then we interpolate here. We get this. We could do it with a lot of ifs and else, but I wonder if we can just calculate it. We can probably calculate it like... I think we can do it like this. Float interpolated point is equal to... or not interpolated point. Float edge factor is equal to interpolate by linear. We have to make sure that it's the correct edges. UV tessellation. Yo, what's up, Jax? The x coordinate tessellates between E1 and E3. Okay. So can we we want to do it like this. I don't think we want to interpolate by linear. We want to do edge factor is equal to lerp. Like, is lerp between E3? Let's do it like inverse interpolation. Let's see what we get. Factors dot edge 1. Why am I having such a hard time? Now we're not doing bilinear interpolation by 4 corner points. We're doing bilinear interpolation between 4 edges. But that should be the same, shouldn't it? Thank you, Viral Air. Yeah, I think so. So Y decides if we're E1 or E3, X decides if we're E2 or E0. Pretty much. So I wonder if we want to do E0, E2. We just want to do a lerp between these two. And then... But how the fuck does this work? Nah, we should be able to just do edge factor is equal to the X edge factor. We do for the X, we should just do a linear interpolation between E0 and E2 with the X coordinate, and then we should do a linear interpolation with E1 and E3 with the Y coordinate. But that means that we have a... So we have a... different factor in X than we have in Y. Okay, so given a point somewhere here, we want to calculate which edge factor it is closest to. But how would that work with a point that is at E2 and E3, or has the same distance to E2 and E3? I mean, we could probably interpolate this point is max of these two, this point is max of these two, this point is max of these two, and this point is max of these two, and then we just do bilinear interpolation. That would be pretty easy. Probably not the most optimal way of doing it, but it will work. So point factor 0. So this one is E1 and E0. E1, E2. Two is E0, E3. E2, E3. So we calculate a edge factor and a edge dynamic factor, and then we want to compare these. I want a dynamic. We pretty much want to do this. Output interpolated point is true if edge dynamic factor modulus 1.0 is equal to 0.0 and edge dynamic factor is less than edge factor. Thank you. Fuck. Oh. That leaves us with nothing. If we do really? Did I? Edge dynamic. Okay. We need to change these as well. Point factor, point dynamic factor. Should be point factor dynamic, but whatever. This type of print is something we have seen so many times before here. Yeah, we're getting This looks pretty good. This looks pretty good. So basically what we're seeing here is for this one, this edge has the same dynamic factor as it has actual factor. This one is subdivided more than it should be. Same with this one, and this is the same. What I'm wondering is why we are getting white here in the center. Doesn't really make sense to me. Edge dynamic. Okay, it does when we have only this. Yes. So our factors are pretty much 2 to the power of something that has been rounded. So we always have 2 to the power of a full number. We should be getting a full number here. Could it be floating point error? We can try and do util math. Compare. Do we have a compare here? Then we can do if this one is less than 0.01. Doesn't change anything. Okay. Fuck, we can't do it like that. We need to do... Or we can. We should be able to... Yeah. Hmm. I mean, we could solve it with the old if-else statement like we did previously. Maybe that's even better, honestly. Let's try that shit. Let's see. Let's just make it work. So if UV, or actually if, yeah, UV tessellation.x is equal to 0. Then we do output.interpolated point is equal to if factors dot edge. So if x is equal to 0, that means that we're down on this edge. So edge 0. If factors.edge dynamic 0 is less than this one, then interpolated point is true. If x is 1, we are at edge 2. If y is 0, we are at edge 1. If y is 1, we're at edge 3. Beautiful, with one problem. Ooh. This one should be black, this one should be black, and this one should be black. So instead of doing this, we do let's take a look at this one, what it actually does. So this one has a okay, let's say that this one has a tessellation of 1, and this one has and it has 1, 2, 3. This one is 3 times as big. can't we do... this, and then we check... This one has 3. What did we say that this one had? Or this one has 1. 3. This one has 3. So we get 1 divided by 3. That's wrong. And divided by modulus factors dot edge 0 in this case -1. I don't think this is entirely correct though. Factors edge 2, 1, 3. I think this one is wrong. Yeah. Has to be a better way than this, whatever this is. Yeah, first of all, I don't think this will cut it. This one looks pretty good. No. So factors, what do we have? Let's take a look at these. We have 1, 2, 3, 4, 5. 1 becomes 2 to the power of 2 to the power of 1. 2, 4, 8, 16, 32. And then we might have, this is the edge, then we have 2, but maybe we get 2 here. 2 divided by 4 is 0.5. I want to see what happens if we do divided by we get 1 here and 1 here, that's good. And then we get 0.5 here, I would say, which is really what we want to get. And then we get .5 here. That's good because this one is subdivided one more time than this one. This one is subdivided one more time than this one. Well, let's do 0.25. Then we get this one, that's good. And then if we do 12.5, then we get this one. And that's beautiful. So this one is subdivided 8 more times than this one. This one is subdivided 4 more times than this one. Or ish. 2 times more than this one. So we calculate this number, and then we do output.interpolated point is equal to uv.x. I'm using uv here, modulus output.interpolated point is equal to I want to double check this. Yes, of course. We want to do this instead. Oh, come on. Okay, so edge dynamic divided by factors edge gives us values that are like 0.5, 0.25, 0.125. And our UV, which we interpolate here. We UV scale and UV offset it. Okay, so what we want to... Let's use UV tessellation here instead. Should work pretty much the same, I think. So for this edge here, we got a value here that was 0.25, right? So these vertices, we have 0.25 here. The UVs of these are, they're actually located at the let's work with this. Okay, 0.25 here, and this is in the X. So for this one, or actually this one. Yo, what's up, Radiant? Yeah, we're doing Tessellation still. Last 10% takes as much time as the first 90% though. So we're at this one, right? X is the Z here for this one. So, oh no, we are at X. Fuck this, sorry. X. We are at y equals 1. So this is y equals 1. So down here, yeah, I'm just gonna test it by doing this. Yeah. So y equals 1, and then we do Edge dynamic divided by edge is equal to 0.25. And then we have the UV here, or y is equal to 1, so x goes from 0.25, that's not true. Radiant isn't using statements in shaders bad for performance. I don't know. They used to say it, but it was pretty much... It's my understanding that you can pretty much assume that the time it's gonna take processing a statement in a shader is as if both statements were executed, pretty much. So it previously, today's GPUs are a little bit better, but flag lots of code and logic. You couldn't optimize your shaders by doing this. So let's say that you have a lot of calculations being done here. Hiding them between a flag like this wouldn't really optimize it, because if you have a group of executors on the GPU and one of them in that group executes this code, all of the other ones are gonna have to wait for that one, making it bad for performance. I don't know. I usually try to hashtag if that would just be a flag to the compiler, right? So you would compile two shaders, one that does it and one that doesn't. But okay, I try to avoid if and else branching in my shaders. But in this case, we're just trying to get this to work, and then we can focus on optimizing it after if we feel the need to. But okay, 0.25 here, what does it tell us? One, two, three, four. Okay, 0.25 tells us that for 4 steps here, every 4th step we have an acceptable point. So 1 not acceptable, 2 not acceptable, 3 not acceptable, 4 acceptable. Now we just need to I wonder if we could do... So if we move a little bit to the right, this one is going to be equal to 0.5, I think. And that tells us that every other step is okay. So okay, not okay, okay, not okay, okay. So .25 times 2 or 0.5 divided by 2 is 0.25. This one, okay. So here we have 0.25. 0.5 is okay. So if we have 0.25, edge dynamic. Okay. So when we have it like this, I would like this one to be 12.5, right? No, 0.5. Okay, beautiful. So we can do, I think it's an interpolated point if UV tessellation X modulus this is equal to I think this. We get, fuck, it's wrong. One sec. Did I fuck up? This is similar to hard problem of consciousness. I don't know about those problems, but what did I screw up here? So here we get 0.25, no, 0.5. But we step every 0.25. Oh, I wonder. So here we step every 0.25, or no, we step every 0.125, but we should step 1 divided by. So I wonder if we want to step. This one is equal to 0.5. We want to step the output dot interpolated point is equal to 1 divided by factors dot edge 3 is equal to 0.1.5. So this is how we calculate the step size. This is how much we want to adjust the step size. So I wonder if we want to do it's an interpolated point if 1 divided by this times 1 divided by factors dot edge 3. So this is the actual step size we want to check against. So we check it's 0.5. So then we check UV tessellation dot x modulus this. If this becomes 0.0, then it's an interpolated point. Get the fuck out. One sec. I'm looking at the wrong one again, am I? This is Z or Y. Or this is X. Yeah, this is walking along the X-axis. And if we would do UV, Y. Okay. What am I missing? These calculations seems to be good. It might be Yes. Yes, okay. For this quad, this point exists here. This one does not. This one exists here. This one does not. Or this one does. This one does not. This one does not. This one does. This one does. This one exists. All of these does not. This one, this one, this one. Okay, beautiful. Now we have it working for one side. Let's do it for all sides. Very similar to a previous solution we did. Extremely similar. So all the black points are interpolated points. We can see here that our center points should not be interpolated. So if nothing of this is true, makes me output dot interpolate point 0.0. Oh, one sec. Yeah, this one, for instance, should be white. No, it should be black. This one should be white and this one should be black. So we want to do... Okay, so the white points, they tell us that for every white point here, we should not, or we should interpolate the position. We shouldn't calculate it individually. So that means even though we have 3 points here, we don't reposition them, right? Okay, beautiful. Interpolate. Looks to be working. Okay, so if we do this now, so when we get down to the domain shader, we send on interpolated point. So every point is marked as either interpolated point or not, and then in create from point we do interpolated point Here we do test times 1 minus interpolated point. So if a point is marked as an interpolated point, it should not change height. This value is 1, so we do 1 minus 1. All of this becomes 0. We multiply 0 with whatever test is. Everything becomes 0, which means we use the interpolated point. But we also need to do this here. It makes me wonder. Yeah, fuck, we're gonna have to calculate the point here as well. Aren't we? I want to take a quick look at this again. So in this case, when we have 4 points or 5 points meeting 2 points, this one is going to be interpolated between this one and this one. This is not moved at all. Yeah, we get the wrong result. Yeah, it's probably much easier to do it the other way. So instead of removing points, instead of removing points, we interpolate here. We add points. We do interpolate here. I'm pretty sure. Wonder how weird shading we're gonna get here. Maybe it's not too bad. So if we mark this point as not tessellated enough and this point as not tessellated enough, we add the correct amount of points between them. And just leave it like that. That is also quite... Yeah, we have to make it work with this one eventually. The markings here, they don't really follow, do they? Not though. So let's see. This point right here, we interpolate it from this point and this point. Both of those are marked as interpolated point, aren't they? Lerp domain shader output. really matter. We get an extra line of interpolated here, which makes me wonder. Doesn't really matter. Here, this one gets marked as interpolated. That's weird. Or actually, no, that's okay. This one shouldn't be marked as interpolated. It's because it's here. Yeah, it depends on how we convert it. We can probably convert it a little bit better. We still have a main problem of offsetting these points, or interpolating these points rather. In this case, it would be amazing yeah, if we split them more, yeah. In this case, if we just do this last subdivision and then we split this into 4 triangles, would work pretty good. But like the best case scenario would be to prep everything in the domain shader and just let the geometry shader do what it always does. So if we could rely on a solution where we don't add extra vertices, that would be amazing. So i.e. not interpolate, or interpolate, 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 don't interpolate, 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 so on. But for that work we would have to, when we do the final split, we get some vertices marked as interpolated that shouldn't be. And that's because we've split one last time. So I want to get... Okay, let's do... I wonder what would happen if we do... one divided by... don't interpolate, interpolate, don't interpolate, interpolate, don't interpolate. Because then when we split, it looks like this. And this is beautiful. This is what we want. Although I would like to exclude these two as well, eventually. Yeah, and if we do it like this, we get this. That's not good. It's better than whatever this is. What a annoying problem. Although this works beautifully. But yeah, then when we do the split quads, we have to refine this one. When we created this beautiful topology, no idea we would be getting these problems, or these complicated problems at the seams. I wonder if... So if we take a look at this one, this triangle goes to... Honestly, I want to do this the other way around. So if we mark vertices, can we do that in an easy way? So for this quad, I'd like to mark edges that should be subdivided more times. That's not as easy. Or what if... No, okay, maybe I'm thinking about this the wrong way. So if we have this... It feels like we're gonna get ugly shading no matter how we do this. Just wonder which way would be the best way to hide it as well. Now we wouldn't get ugly. We would get long sort of thin triangles, but it would be okay. So in this case, we would get a... I don't know about this. 1, 2, 3, 4, 8. Okay. This one, I'm a little bit worried about this one. Okay, in this case, this one is marked as interpolated, this one interpolated, this one interpolated, and that's fine. The problem is that this one is marked as interpolated between this and this. if we would like to calculate our height for these three, let's not worry about the split for now. We would need to read the height here and read the height here. We do modulus times whatever it is and then plus whatever it is. Then we get this point and this point. Yeah, let's try that. This approach... Okay, so in this approach, we're gonna interpolate these points so that they have the same height as this triangle. And we want to double check if we get some flickering artifact from the rasterization because of floating point errors. If we don't, we can probably go with that solution. We just have to make it work for this one as well. Shouldn't be that hard. We'll see. So we're gonna do sort of an ugly thing here, I think. But I would like these to be... But before we create the UV here, we would need to... That's not entirely true. Yeah, if we do it this way, we're gonna have to read neighboring values. Yeah, that is gonna suck, but UV step. Best way to split it later on, if we do need to add new vertices here, would probably be to split it in the middle here. So we drag a line here, and then we do, so we have this point, then we can split it like this, this, this. And if we were going like this, we add a point here, split it like this, 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 and this. Yeah, that would probably be the best way. But let's worry about that later. We need to calculate interpolated function or positions for these 3 vertices here. Easier said than done. We have them marked. We remove the geometry shader for now. We have them marked, so if output interpolated point is true here, we need to do something. The best way would probably be to do it in here. So this one is marked, for instance, then we want to walk along this direction, and we want to walk Yo, what's up, Ling Ling? How's the progress? Pretty much non-existent, but hope your meeting went well, at least. Doing the seams between these subquads turned out to be way harder than I expected, or way more complicated. Pretty much non-existent. Okay. That's most meetings, in my experience. So this one, it gets marked as interpolated point, then we want to find this point and interpolate between. Having worked with Tessellation this intensive today has really made my brain fog. To the point that I pretty much can't, like, I'm at the point where I'm having a hard time understand your last sentence, Ling Ling. That's where I'm at the moment. As for this system, I hate the fact that we need to check neighboring points here. It sucks. I never got to Tessellation in Vulkan, seems I got lucky. Like, as long as you only rely on the default Tessellation, it's pretty straightforward. But as soon as you start going a little bit outside the boundary, becomes real complicated real fast, I would say. Yeah, so like in our procedural grass, we do tessellation. We do it on triangles, POW 2, and we just let the hull shader and hull patch constant function do its job. Our domain shader, it pretty much only interpolates, and then we're done with tessellation. Everything works, we get correct seams, everything is beautiful. But this, when we want to do some weird topology stuff, then it becomes messy real quick. Yeah, I mean, I enjoy both, like OpenGL, Vulkan, all of those stuff is really fun to work with. Actually, given this point, we just remove the modulus and then we add. It should be straightforward. So if we do UV tessellation Y, oh, it's gonna be ugly. UV tessellation Y modulus this. And then we do if output dot interpolated point is not equal to 0.0. So when we get to this point, that means that we, yeah, then we just want to take minus and plus, and then we have the 2 points. So the bad thing is calculate the normal. Okay, for now we don't care about the normal. So we just do I'm gonna have to do this again. So we'll float 2. UV or P1 UV is equal to UV tessellation or actually is equal to float 2 0, and here we do UV tessellation dot Y minus My front-end buddy does react to jokes I posted on project server, but not to my question and requests. Fuck man, that sucks. P1 UV is equal to I mean, the reactability of teammates when they're getting paid for their work is a little bit better than when it's free work or school projects and whatnot. But it still happens. Fuck, my brain is fried. What do we want to... We want to remove... Yeah, here we also want... Factor, yeah, we're gonna do it like this. Factor is equal to whatever this is divided by this one. So we have the rest and we have the factor, and I'm just gonna do round. Or floor, do we have floor? Like this. So our first point is actually, let's do this. Don't think we want rest, we want... So we create UVs that are factor times step and P2 UV factor times step plus 1. Oh, I get it, Ling Ling. Then it sucks extra much, I would say. Fabric, Welcome back, by the way. Almost missed you. The problem I'm seeing here is that you shouldn't have chunks having 2 steps difference in tessellation. We will probably never get chunks that have bigger than 2. We might. But I mean, that's like, we could simplify the problem by adding that constraint, but it wouldn't really solve the problem, right? We should be able to handle both of those cases. But like, this will work. This will be generic enough so that so basically what we will calculate is we will calculate this point and we will calculate the step it should take. So here we have a lot of them. So what we do is we calculate 2 UVs for this one. We round it down so we get to this point, and then we add 1 step to get this point. So then we get this full one. So then we calculate the height here, we calculate the height here, and then we just interpolate based on our original UV. I am done. And it will work even though we have X tessellation to X plus 3 tessellation, or if we have this, or if we have... Yeah, it will work in all cases. It's just that it's extremely... It's a little bit complicated. But as you say, Fabic, if we would be able to limit it to these types, so we only have 1 extra tessellation between neighboring rain patches, that's just a question about making this larger, like this. Then we could simplify the solution quite a lot, I think. For this point, yeah, we're still gonna have to recalculate this point. The easiest way would be to add points here, because then we have the original ones. Hello, where do you get your background music? Chillhop.com, it's in the description. Highly recommend them. Beautiful music that can be used for videos and streaming. Yeah, like constraining it like this, as you say, Fabic, that would definitely help us quite a lot. I'm not sure I'm not ready just yet to take that step, though. Like, unfortunately, I need to run soon. I would love to keep grinding here, but I think I have some other stuff I need to do, and yeah, I'm having a hard time doing this right now anyway, so it might be for the better. But just to summarize, the approach we're currently taking is that for the seams here, we identify the points that exists for one quad but not for the other one, and then we just reposition them based on the points that do exist. So we do an interpolation. This is gonna work. It's gonna make our seams disappear. I am worried, however, that we might be getting some rasterization issues, but we're gonna find that out. If we find some rasterization issues, to make this solution work, we're gonna have to subdivide this one as well. So we can not only interpolate these points, we need to subdivide this one and interpolate those points as well. You can always get sort of weird rasterization results when you have two triangles, or when you have two meshes that should be located exactly at the same point, but they don't have the same vertices representing those points, sorta. I have no doubt that we will fix this, hopefully tomorrow. It's just how we fix it. I'm gonna do my very, very best to be done with Tessellation this week, because I don't wanna... I wanna take a break from it and work on something else. So yeah. Hopefully we will be... Hopefully we will manage to complete it tomorrow. But yeah, I gotta run. Thank you so much for watching, everybody. Appreciate it. All input as well. Have a great rest of the day. Peace.